Hello everyone. As part of my series where I'm helping you understand how SQL works and what happens behind the scene and how indexes work, in today's session I'm going to cover the table partitions and how they are useful. As part of this session, I'm going to cover why partition is required, what are the different types of partitioning, what are the things which you should be considering when you are planning to partition the table, and then last would be the partitioning of indexes and how they are related with the partitioning of database tables. Alright, so why partition is required? In nutshell, partitioning is nothing but breaking a table into a smaller pieces. And that should be done when you have millions and millions of rows. That is where you want to break your tables into smaller chunks. One of the obvious reasons why do you need it is to achieve a faster performance at the time of a retrieval, because you have a smaller data to query from. The another advantage of having a partitioning is easy maintenance. So if you have, let's say, millions or more than 100 millions of rows, and if you have partitioned your table into a smaller chunks, then at any point in time, let's say you want to collect the statistics or you want to get rid of a specific data set based on the partition, you can get rid of the entire partition in a one go itself. So that is going to be a fast, easy to maintenance. The another one is availability as well. So just because you have broken your database table into multiple smaller pieces, availability of a one piece or a problem with the one piece is not going to impact the another one. So that's one of the third advantage of using partition. So let's get started with what are the different types of partitions. On a high level, there are two partitions. One is a vertical partition and another one is a horizontal partition. To explain vertical partitioning, let me take an example of a table which has multiple normal columns, and it has one column which is a blob type to store large data. Now, when database retrieve anything from the table, it retrieves in one chunk called as a block. Now that block is typically of a size 8 KB. What it means is that in 8 KB, if it can fetch 5 rows, then if 5 rows fit into those 8 KB, then it is going to read all 5 rows in a one read itself. However, if you have a data set like this, then it is possibly that your last column itself is going to take a much bigger space. And when that happens, database probably will not be able to get the optimization because it is reading the data into a chunk, because every row probably is fitting into one particular block itself. So it is reading one row at a time. Now to improve the efficiency around that, you can partition the tables such that all the columns which are normal size columns go into one partition and the blob columns goes into another partition. Here we did a partition by the columns, and that's why it is called as a vertical partitioning. Now in this particular case, if database wants to retrieve all non-blob or normal columns, then it will just query from this data, and in this particular case, when it is pulling the information from the 8 KB blocks, it might get multiple rows in one go itself, and that's where the efficiency is going to be. If because of any reason you need to retrieve the data from the blob as well as the columns, that is the time database is going to retrieve the data from the two partition and then it is going to merge it. So again, this could be a good strategy, but at the same time you need to think about that what your retrieval strategy is, or what is your retrieval requirement is, because if all the time you need to read the blob, then probably your first non-partition table itself is good enough. Okay, so let's talk about the horizontal partitioning. So as vertical partitioning was partition by columns, horizontal partitioning is partition by rows. So if you have a millions of rows in your database table and you do want to create a multiple different partitions by so that each partition have a limited number of rows, So in this example, I have taken an example where I even mentioned that this one key, let's say that we are storing the employee data, and maybe let's say for government organizations where the employees there for the center as well as the state and for the entire India. So you might have one column which says that what is the state of the employee. Now you want to partition this table horizontally. So one of the option could be that you partition it by the state itself, which means that for all the employees which belongs to Rajasthan state, you put it in one partition. Everything which Tamil Nadu is in a second partition and Maharashtra in another partition. This way you have broken the table horizontally. You broken by rows. The advantage of this is that your data is stored into a chunk, and when you want to retrieve the data, you probably, if you are just looking for the data for a given state, then you are just looking at one partition that time and no other partition is getting involved, so you got a faster retrieval. Now let's talk about a scenario where you have a retrieval query but that do not include partition column in its where clause. So in this particular case also, database retrieve the data from each of the partition or multiple different partitions and then collected the data and given back to you. So as a consumer, you would not realize that what database is doing behind the scene. At the same time, you can imagine that if you are trying to retrieve a data where your query do not include the partition key, then database has to do extra work to go to each of the partition and then fetch the data. And it could also be possible that that particular time not having a partition in first place might have been a faster response time. Alright, okay, so let's talk about what are the considerations which you should be thinking at the time of partitioning the table. The first one is obvious from my previous example, is the choice of a partition key. If the partition key you choose is not used in many of your retrieval query, in that particular case, database need to do extra work to go and look up in each of the partition and get the data and then combine all the data and give back to, return back as part of your query, which is going to be slow if most of the time you are retrieving without involving your partition key. If your query where your retrieval involves the partition key in its where clause, that means your database is looking at only one or two or few partitions as opposed to going through the entire, all the partitions or going through the entire table. So you should always think about it that whenever you are going to retrieve the data, is there anything which is most commonly used while retrieving the data? In this example, let's say if most of the time you are interested in looking at the data of one state or two states at any point in time rather than looking at the data for the entire country, then state is a good partition key. But if your most of the queries probably are going to look up the data at the entire country level, or you would not know what state you are looking for, then it is better not to even partition based on the state. The next one is the partitioning methods. So there are multiple methods database provides how you can do a partitioning of a database table. All these are based on the partition key which you have chosen. So for example, in the previous example, when we talked about the partitioning by the state name, we did use a list partitioning. In this particular case, when you are creating the table and when you are writing or creating the partition strategy, that time you specify that, okay, I have a fixed set of partition I need to create, and value of the column decides which partition the data will be going to. So you might decide one partition per state, or you may also say that I do want to have one partition where I'm going to include few states, maybe with a smaller population in one single itself. So you can specify that, okay, one partition have list of, let's say, 3 or 4 states. The another one is a range partition, which works more for the numeric kind of thing. So like, for example, if you want to have a partition by, let's say, age, or you want to do a partition by salary, or you want to do a partition by a date range as well. That's where you would be using a range partition, in which case you specify that okay, this is the key on which I want to do a partition, and you specify the start and end of a particular partition range. In that particular case, any value of that particular field falls into the range given for a partition, and then that data will be moved to the respective partition group. Hash partition is where you do not have a fixed set of values. So for example, you do not have state, you do not know what all the different states are going to be coming. Or second thing is you want to do a more of a equipartition. So for example, you want to do a partitioning of your table based on, let's say, employee name, because you know that employee name is always there in your select criteria. But you do not know what are the different names which are going to come, so you cannot use a list partitioning, because you cannot start specifying the name of the people at the time of defining the partition itself. So that's why you would be using hash partitioning. In that particular case, database behind the scene, for any given data, it will try to find out what is the hash value of the column, and based on that it will do the partitioning. It is also equipartition, because in this particular case, database is not making a decision that number of employees belong to a specific state, but it is more or less just identifying the hash value of this of the data, and which is supposed to go into equal distributed. So that's why each of your partition is supposed to have a relatively a similar number of rows. And you can also have a composite partition, where let's say you want to partition first your table based on the state, and within a state you want to partition people based on range, let's say age. So you can also do a partition, and in that particular case it will be called as a composite partition. Alright, so let's move from partitioning of the table to a partitioning of the indexes and how they are related with each other. So in terms of the indexes, there are basically three types of partitioning which is possible. The first one is a local partition index. In this particular case, as you can see in this diagram, if there is a partition table where it has a multiple different partition, then local partition index will be one partition of index per partition of the table as well, and this index is limited to fetch the data only within a single partition. Typically how that happens is if your index key also includes a partition key. So for example, if your index says I want to have an index on, let's say, state name and the employee name, and if the state name is a partition key, state, employee are always going to be in a single partition. So your index will be a local index in that particular case, that it is primarily searching for the data within one partition for a given employee name. The next one is the global known partition index. In this particular case, there is a one index which has been created, and that index is suffice for all the different partitions which your table might be having. Index is not partitioned here, and it's a global index. Where you would need this kind of index is, let's say that you have a unique index, or you have a primary key, which is supposed to be a global index, because when you want to create a unique index, regardless of which partition the data belong to, you want to ensure that this uniqueness across the table. So that's where your unique index or a primary key index is usually global non-partition index. Alright, the next one is the global partitioned index. In this particular case, your index is partitioned independent of your table partitioning. You give column choices for the indexes also on which the index is supposed to be partitioned. So as you can see in this diagram, the index is partitioned, but at the same time this index, one index might go and have pointers to the objects in the different partition altogether. So like first one in this particular case has one field or one row of the first partition, at the same time it has another row of second partition, and then it has a third row of a different partition altogether. So here the partition index is completely independent of the partition table. The keys of the partition index is completely independent. Alright, okay, so in this particular session I talked about partitioning of the table. What are the considerations which you should be thinking when you're defining a partitioning strategy for your table, At the same time, how the indexes should be created, or what are the different choices you have when you want to create a partition indexes. Thank you everyone.